So today I'm going to be talking about Oracle extractable value, and I did like a little bit of initial crowd research, and there's like everyone from like super crypto OGs here to like people who are just looking into crypto this week. So I'm going to try and keep it a little bit simple, but feel free to kind of come up to me whenever and ask. And also this whole talk, so this is like a work in progress theory. We've just been kind of writing down some of our ideas on OEV over the past few months, and we'd love your thoughts on any of it and anywhere it's going to go. So before I'm going to get started, so I work at Tellor. How do I go back? There we go. Cool. Little delay. So I'll just give you a quick intro about me. So I'm CTO at Tellor. Tellor is a decentralized Oracle on Ethereum. We'll get into what an Oracle is, but so basically, to go over how Tellor works real fast, we require you to stake 100 of our coins, and then somebody can come and ask for the price of Bitcoin, and you can put on chain the price of Bitcoin. Really simple, but you can lose those 100 coins if you lie. So it's just a simple, super crypto economic Oracle. There's some cool security guarantees, and obviously a little bit more than that, but that's like the TLDR on Tellor. As far as me, I was actually former, I did not click that. I was a former government regulator. I worked at the CFTC back in 2015 to 2017, was on their blockchain team. And then I left to do a decentralized derivative startup, got an Ethereum Foundation grant, which was super cool. And then whenever you're doing a derivative, is this like timed or something? I don't know. Super sorry. Yeah. No idea. But so anyway, so you run into the Oracle problem basically. During my Ethereum Foundation grant, we sort of tried to come up with a good way to solve the Oracle problem, and that was Tellor. So we stopped doing derivatives in 2019 and decided to focus on the Oracle problem, which is, the slides are ahead of me, the Oracle problem. So the Oracle problem, I'm not clicking this. So I don't, yeah, I feel like somebody else is clicking this for me, so you AV guys up there. Anyway, can I go back a slide? Thank you. The Oracle problem is, how can data be brought on chain? So if you guys know how Ethereum's and smart contracts work, everything has to be deterministic on a blockchain. So if you run a smart contract now, you should be able to look at that code and run the smart contract based upon the state of the chain in 1 year, and you should get the exact same answer. Everyone, this is, you want to verify, don't trust. And the problem with APIs is, if you have APIs in the code and you call the Coinbase API now versus you call it in a year, well, you're going to get different answers. So to get around this problem, you just require everything to be an input into a function. So somebody has to actually place the value in there. The problem is that can be a point of centralization. That can be a point that, it's hard, and that's what's the Oracle problem. And the Oracle problem is bigger, so we're going to go over a lot of pricing examples here. So usually, you're betting on the price of Bitcoin, but oracles are bigger than that. You can talk about whether or not you're bringing Bitcoin block headers on so you can bridge Bitcoin. That requires an oracle, or whether you want to bridge any of these chains. Almost all of the designs require oracles. So it's definitely a lot bigger. If you're talking about, any real world asset you want information on there, requires oracles. So it's a much bigger problem than prices, but sort of the structure for solving it, you can definitely just talk about prices. So next slide. Thank you. So a quick example of an oracle in practice. Let's say, Bob and Alice are betting on the price of Bitcoin. When I wrote these slides, Bitcoin was like 30 grand. So if Bob says that in a week it's going to be over 30 grand, Alice says it's going to be under 30 grand. Thank you. And then the week goes, they both place, say, an Ether into the smart contract, and the winner's going to get both Ether. A week goes by, and who gets to say what the price of Bitcoin was? This is the oracle. Whoever gets to say what the price of Bitcoin was basically decides who controls those 2 ETH. And if it's centralized, you might as well not even use a smart contract. They control who gets to say who owns the money. So this is what the Oracle problem is. And we're going to talk about it a little bit today. Okay, so before we get into Oracle extractable value, a lot of you probably have heard of the term miner extractable value. So just to go real fast over what miner extractable value is, we're going to talk a lot, I'm going to kind of go over what information asymmetry. And you can see over here on the left, we have 4 guys who are all going to do their transactions. The first guy has a small gas price, the second guy has a medium gas price, and the third guy has a really high gas price. They all submit their transactions to their nodes that they run, and it goes to the mempool. And what should happen is that the miner should order these transactions, and he should put the guy with the highest gas price first, and then he should put the medium gas price, and the 2 guys with the low gas prices down at the bottom. But he sees that, oh man, that guy with the really high gas price, he's trying to, do some trade on Uniswap that's going to make him a whole bunch of money. Why don't I just put transaction M, or the miner's transaction, in front of him? Now I can run that. So he places his transaction in front of those other 2 guys, and both of them fail because they were trying to do the same thing that the miner was. He ends up winning, and the miner extracts value from the system. So it should make sense to you guys. The problem is basically, the miner can see things that they can't. So he's monitoring the mempool, and he can act in front of their transactions. And this is sort of the same. How do we sort of make sure that everyone's sort of playing on a level playing field? So on the same note, what is Oracle extractable value? Oracle extractable value is basically the exact same thing. So without OEV, let's say you have some sort of DeFi app where then you have an Oracle update come on, and then people can react. So, like say a stable coin or something where there's like a fair value, a derivatives contract. If an Oracle update comes in and then say some liquidations need to happen, well, all of the users of your protocol, they can be monitoring it, compete for, this little profit that you can make due to the fact that now the fair value is different because the Oracle price changed. Well, with Oracle extractable value, the person who's running the Oracle, he knows what it's going to be. He can sort of see the Oracle update before it happens. So he's going to make all of those really profitable trades either right when he updates it, or even he knows sort of, sometimes he might even know beforehand and be able to make those trades even before he broadcasts it to the mempool. And that's what we're trying to prevent here. How do you sort of stop that from happening? How do you, we'll get into it. So this example, this was one that was in the news. I know there's a Maker guy over here, so Maker denied that it happened. It's really, really hard to prove. So DYDX is over on Arbitrum, and Maker is their Oracle over there. Maker has basically a group of something like 15, 20 some people. They're whitelisted Oracle, and they can do updates. And some people were saying that they were front running their own Oracle updates. They were being accused of doing this, and Maker denied it. But it's one of these things where it can happen. It's starting to happen. People know that there are profitable trades whenever an Oracle update happens. So people are starting to pay attention. Oracles are starting to pay attention, and there's a huge opportunity for oracles to sort of jump in front of users. And what that does to your protocol, it's similar to miner extractable value. Is it good? Is it bad? It's definitely worth thinking about. So this is my, I'm an economist by training, so I have to draw graphs with profit opportunity in there. So on the first one, you have, without OEV, whenever the Oracle update happens, there's this nice profit opportunity for users. And then on the bottom, when the Oracle update happens, there's no profit opportunities for users. So it sort of takes it away, and you give it all to the Oracle. And could this be a problem? Well, similar to Ethereum mining, the only way this is really a problem is, well, who are your oracles? If your oracles are, a set of whitelisted people, that can be a really big issue, because If they're given special privileges in the network, basically any DeFi app that's using them is giving those people special privileges to make a profit. If it's more similar to, say, like mining, where it's more of an open network where anybody can be the oracle, then you can make a sort of a more fair, I guess, assessment of what's going on. You know, similar to how with MEV, a lot of the solution, so if you guys are sort of following it, a lot of the solution to MEV is around, well, how do we sort of reduce this information asymmetry to allow anybody to take advantage of MEV, allow anyone to be a miner? And that's what we're sort of going to focus on here. How do we allow anybody to become an oracle so that way this won't happen? Okay, and so this is just a generic slide. This is a block. This is how, you know, we're going to kind of get into. So the big issue with these cartelized oracles, so whenever you have these whitelisted oracle services, this is really where the crux of my talk kind of comes in. Is my theory is that, well, if they basically make this extra profit, or I think I want the next slide. If oracles get this extra profit, the people who are not the oracles don't get that. And mining, especially in Ethereum, is a super cutthroat world. So, you know, you could say, like with MEV, all miners who do MEV are going to push out all the miners that don't do MEV. It sort of makes sense. It's super cutthroat. It's turned into this hardware race where, you know, every sort of cent matters, and it's basically a zero profit game. And the same is going to be true of OEV. Miners who partake in OEV are going to push out miners who don't partake in OEV. So if you're in the future, whenever all of these DeFi apps are requiring more and more oracles, and there's lots and lots of profit opportunities, the miners who themselves are doing OEV will push out those who don't. And if you have a cartel, say a white list of, you know, even 100 people who are your oracles, the problem is that they can also become your miners. And they likely will. This is going to turn into where your oracles become your miners in the same way that we're starting to see the people who are doing MEV are becoming the miners. So they're getting really, really tightly linked. The people, you know, basically these prop shop traders who are going up there, they're buying miners. They're working directly with the miners in order to get MEV directly at the source, and they don't have to do it. And this is a problem for Ethereum. This is a gigantic problem because if you're competing with each other, you want sort of healthy competition, but you don't want competition that doesn't require people to share. That causes everyone to keep closed doors, and it quickly becomes a hardware race. So this was a problem in traditional finance. So back whenever I was at the CFTC, you know, the big thing was high frequency traders. This is what mining is turning into, and this is what basically OEV is just going to give an advantage to those whitelisted people. In traditional finance, if you guys don't know what happened, once high frequency traders came about, is you had, you know, first it was like getting the best PhDs on board, and you would want to try and how can we, you know, make the best strategy we possibly can, and quickly, you know, you sort of have diminishing marginal return on that. It gets lower and lower, and then what happened is, well, it turned into a hardware race. So firms were literally building laser towers between New York and Chicago and all over the world so they could pass information back, and then it was the best capitalized firms were the ones who ended up making a lot of money. These are like the Jumps and the Virtues of the world. And you're going to see similar stuff happen with miner extractable value. If it's, I'm sure it probably already is happening, where they're building hardware connections. And what we don't want to do is give any sort of special privileges to the people running centralized oracles. So, okay, so how to solve it? The big way is similar to like miner extractable value. It's something that we have to think about as from a technical level. So if you're a DeFi app, make sure you're using oracles where anybody can partake and be an oracle. Make sure you're doing things that don't, you know, similar to like with miner extractable value, using oracles on like a TWAP basis. You want sort of slower things. But I think a big piece of it's just going to be a lot of cultural changes, similar to how like some of the biggest problems on Ethereum aren't necessarily. It's really hard to build incentives directly into them. So how do you get people to run a node? Probably one of the biggest questions here on Ethereum, but it's super hard. And it's just one of those things where we have to make a culture from the get-go. If we could all go back to 2016 and get people to run nodes more and make better software, that's what we want to do. And this is where we're at in Oracle. So like Oracle land, like basically like everyone right now just uses centralized oracles. Like there's like centralized or pseudo-centralized oracles. They're all sort of working on decentralizing themselves, but it's just a really hard problem that we've sort of like glossed over. And now we're starting to build these, so we have to, from sort of the base that we are at now here in 2021, moving forward, we have to make sure that, okay, this isn't accepted from a cultural standpoint because we know where it's going to lead. It's going to lead to a cartel of oracles who run laser towers and take over the entire network, and it's centralized and they don't broadcast their own transactions. So we'll stop that. So yeah, basically just how to use an oracle properly. It comes down to this. Making sure that what we build as far as these DeFi apps, whenever it comes down to, okay, well, what kind of oracle should I use? Should I use a centralized oracle that can update every single block? Or should I don't know, maybe just put it up to a DAO to vote on it? Like, it'll be slower. The UX will probably suck. But you have to think about it, and these are hopefully the apps that we can start building, and these are some of the things that we can sort of see on Ethereum. So that's my talk. I'm Nick from Tellor. If you guys need an oracle in your project, think you might need an oracle in your project, come reach out to us. And it's super great to see you all. Can I answer? I don't know, how much time do I have?
Why don't you just use Chainlink?
Yeah, so he asked, why don't you just use Chainlink? So Chainlink at the moment, they're kind of one of the centralized oracles. So, they have a whitelisting process, and they have some plans to decentralize, and hopefully they do. But yeah, like at the moment, they're a little bit of the problem. So yeah, any other questions?
What's Tellor do that's addressing?
Well, you just sort of, so the big thing that Tellor does is that anybody can do it. Similar to like how we solve miner extractable value, like you want anyone to be able to be a miner and anybody to sort of be able to compete on that. Proof of stake solves it, and it's going to be a constant issue. So we just require you to stake, $5,000 worth of tokens, and we think that that's, an amount that more people can do. Because there's like, the first step is just allowing anyone to do it, and then the next step is making sure that everyone does it. And that's kind of where we're at in trying to move Tellor forward. Yeah.
How does the validation happen when you participate as an oracle?
What do you mean?
So if you lied about the price, how do you lose your coins? What happens?
Yeah, so he asked, so how does the validation happen? So with Tellor, if you you have token stake, somebody asks for the price of Bitcoin, you put on and say the price of Bitcoin is $20 million. Anybody can say, hey, he lied about it, and then it goes to a vote of token holders. So it's like, the multiple rounds of voting, a la Augur style. I won't steal it from anyone. And then, yeah, you lose the money. And the person who wanted the price of Bitcoin, he just requests it again. So somebody else will just put the price of Bitcoin on. And that's why it's one of these things where it's all about, it can be as fast as you want if you're willing to pay for people's gas. So you would request it. Oh, well, that person was wrong. It comes on again. Well, that person was wrong, and then it comes on again. And then however many miners are in the system, it can sort of be as fast as you're willing to pay for. So anything else, guys? No? Oh, cool. Thanks for listening.